Hello dear students, in this video I'm going to solve Isaac Physics Pre-Uni D5.1. So question is D5.1. Let me read the question first, then I will explain. Consider a particle that is at an antinode and of a stationary wave, which we will call point A. Fill in the table below to state how the motion of certain other particles will compare to this one. Okay, now here is the I made the diagram first. For example, we have a stationary wave, and this stationary wave is just like here. You can see that this is stationary waves. One wave is going in this way and the other wave is going in this way, so they make a stationary wave. Here is the stationary wave, complete stationary wave. Okay, now so one point is at the A, that is antinode. Here this point is antinode. The highest amplitude is A, above a mean position. So this is, for example, central line or equilibrium position. So this A is the antinode. Okay, now we have to compare with this antinode with the next antinode along the point A. So next antinode is clearly, as we know that this point is going downward. When this point is going downward, so the next this point is going upward, so next antinode is below that one. This is next, because before that we have a node is those point which has zero displacement, and antinode those point which are moving and which has maximum displacement. Okay, so we are dealing with the next antinode, and then next antinode is here below downward. Okay, so first amplitude. Remember that the amplitude has the same maximum amplitude. Antinode has the same maximum amplitude. Okay, so below that the next amplitude is also the same. Okay, the amplitude compared to point A, the next amplitude also is the same. Okay, so we can see that the amplitude compared to point A, the next antinode also has the same amplitude. It means next antinode, so I suppose that this is A dash. So A dash is exactly same as the A. Next antinode, that is A dash, has same amplitude. Okay, so correct option is same. Okay, now remember that amplitude is the maximum distance from mean to extreme position. So this is the amplitude. Okay, now for the part B, we have to find the phase relationship as compared to point A. So we have again I made the diagram again. For example, we have a stationary wave pattern just like that, and another wave that is going in this way, that is wave that is going in this way. Okay, now this is a stationary wave. Okay, you can see that. Sorry, I have to make the diagram again. 1 minute. Here we have a stationary wave, complete stationary wave. Here we have a complete stationary wave, and we have to find the phase relationship between these. Okay, phase relationship between A and A dash. Okay, remember that this point is at the highest point, so this point is going downward, its direction is downward, but this point is going upward. So so it means that they have the antiphase. They are antiphase. These 2 points are antiphase. Their direction is opposite, so they are antiphase. So A and A dash are antiphase. So what does it mean? It means they have the 180 phase difference. Okay, one more thing you can also judge from what is the phase relationship. So always remember that the two statements are important. One is the points that are separated by odd number of nodes. The points that are separated by odd number of nodes, odd mean 1, 3, 5, 7, okay, are 180 out of phase. The points, remember the formula, the points that are separated by odd number of nodes, they are 180 out of phase. They are 180 out of phase, mean the phase difference is 180. Mean if you can see that A and A dash are separated by one node only. Okay, when they have one node, so it means if this particle is going downward, this particle is upward, so their direction is exactly opposite to one another. So it means all the particles on this line and all the particles on this line, they are an anti-phase, exactly 180 out of phase. So the correct option is 180 out of phase. Okay, so similarly the points, if the points are separated by even number, means 0 to 4, mean the next, for example, if we compare another point that is here in this way, you can say if we compare with the other point, that is this B point, if you compare A and B, so they are also the same. Okay, they have no phase difference, so they have even number. If they have an even number difference, because we can say two nodes, there are two nodes between, mean if the two points are separated by even number of nodes, mean the two nodes, we can see the two nodes are there, so 1 2, A and B are separated by two nodes, so it will be even number, so they have no phase difference, no phase difference. Okay, but in this case, in our case, we know that there is a these A and A dash are separated by one node. They are separated by one node, mean one node mean odd number of nodes, odd number of, and it means they are 180 out of phase. So always remember this formula. Okay, thank you.